Hi everyone, this video is on question 3 of exercise 9H, which is about implicit differentiation. So in the previous video, we showed some of the basic results that we can apply them to uh, differentiate functions implicitly. And now in this exercise, we are going to use that. So um, let's start with the first one. X squared plus y cubed is equal to 2. So when you want to differentiate this and use implicit differentiation, because one first and natural question might be that, okay, but why just don't we rearrange that and write the function in terms of x and then just differentiate as usual? And that's a very interesting question. And the problem is that in many cases, we can't really rearrange that, or just the rearranging is just going to be too much work, and we don't want to do that because there is a much simpler way, which is implicit differentiation. So that's why we tend to use the implicit differentiation in cases like this rather than rearranging and then differentiating as usual. So in this case, x squared plus y cubed is equal to 2. So if you want to differentiate this using implicit differentiation, that's actually very simple. So you just differentiate everything as usual, but since y is your dependent variable in this case, you differentiate x as usual, so nothing changes. For example, in usual case, x squared differentiates to 2x. That's the same here, so nothing complicated. Now, when it comes to the dependent variable, which is in this case is y, you differentiate y as usual, which I will show in a second, but you also write an additional term of dy dx whenever you differentiate the dependent variable. So let me show what I mean. So we said we differentiate x or the independent variable as the usual way. So x squared differentiates to 2x, no problem. And we said we also differentiate the dependent variable as usual, and so y cubed differentiates to 3y squared, and we always write a term of dy dx as basically it's being multiplied to that. So that's the only difference. And 2 differentiates to 0. And the rest of that is just a simple rearranging because we want to have dy dx in terms of x and y. So that means we write 3y squared dy dx is equal to minus 2x, and divide everything by 3y squared. So we get minus 2x over 3y squared. And that's the derivative. So I know this includes the term y, which is, again, not very usual because in the normal differentiation, we just get everything in terms of x. But that's fine. In implicit differentiation, that's fine. And it's not an issue. So as you can see, this is much faster than rearranging the function in terms of x and then differentiating that. So now let's do d. All right, so we have y cubed. Again, we differentiate that as usual, which is 3y squared, but we always write a dy dx term whenever we differentiate the dependent variable. And now here is very interesting. The next term is 3x squared y. So just remember that this is actually the product rule because you have two different functions. One is 3x squared and the other one is y. So we need to use the product rule. That's very important because it's a very common area for error that you might just differentiate this as if it's just a single function. For example, differentiate this as 6xy, for example. But it's actually the product rule when you have both x and y in implicit differentiation. So we can first keep the first function and write down the times by the derivative of the second function. So the derivative of y is just 1. And we said that we write down the derivative of y as the usual sense and then times that by the dy dx. In this case, 1 times dy dx is just dy dx. So that's the first term of the product rule. The second term is the derivative of the first function, which is 6x times the second function without any changes, which is y. And finally, minus 4x differentiates to minus 4 is equal to 0. Now it's about rearranging. So we can factorize and take a factor of dy dx. Then we have 3y squared plus 3x squared is equal to 4 minus 6xy. And finally a division. Dy dx is equal to 4 minus 6xy divided by 3y squared plus 3 squared. Okay, and finally f. So f is just very similar to d. The only difference is that we just need to use the cross multiplication to just have this in a nicer form. So we can have x times x squared minus y is equal to 2y, and then expanding is x cubed minus xy is equal to 2y, and then rearranging x cubed minus xy minus 2y is equal to 0. Now we are at a position to differentiate this. So if you differentiate this, the first term differentiates to 3x squared, that's fine. The second term, which is this one, again needs the product rule. So we first write down the first function, the derivative of y is just 1, and then that times dy dx is dy dx. Then the derivative of the first function is just minus 1, and minus 1 times y is minus y. Minus 2y, so minus 2y differentiates to minus 2, and always the derivative is being multiplied by dy dx is equal to 0. Again, we just need to rearrange this. Dy dx is equal to, dy dx times minus x minus 2 is equal to y minus 3x squared. And finally, dy dx is equal to y minus 3x squared divided by minus x minus 2. Of course, if you like to have this in a nicer form, you can multiply all the terms by minus 1, or just take a factor of minus 1 and simplify things. But I'm just going to stop here. So that's it for this video. And in the next video, I'm going to solve more examples from this question. Thank you for watching.